So, good day once again. Um, Here we're going to talk about phosphorus cycle. Just like we discussed the previous cycles, the phosphorus cycle is a bit different in the sense that based on categorization or classification of biogeochemical cycles, we mentioned that there are gaseous and there are sedimentary. So one of the example of sedimentary cycle we cite is phosphorus cycle. Why is it different from the rest is the fact that it does not involve the gaseous form. So we have by definition a movement of phosphorus we can say from one form to another, even though basically movement of phosphorus in this case involve the soluble and the insoluble aspect rather than the change in form. So from the lithosphere to the hydrosphere to the biosphere, excluding the atmosphere. So before we go into that, then we talk about the biological role of phosphorus. What are the biological role of phosphorus? But before then, we need to know that the fact that it is the slowest biochemical cycle, and we have it being one of the most limiting element in our ecosystem. Being it's one of the limiting, I think we will see some of the process and we'll explain better that in algal blue. So what are these biological role? The biological role, we know that it is one of the genetic component of genetic material in RNA and DNA, and it's also component of the energy molecule ATP, component of phospholipid of cell membrane, and the structural components comprising of up to 80% of bones and teeth, and some other metabolic intermediate like NADP. Just to mention a few. So just imagine a life without phosphorus and how possible these molecules cannot be produced. It would have been catastrophic. In fact, molecules or life may not exist. So the cycles must keep going for the survival, for the continuous survival, or the existence, let's even say, for the continued existence of living on the earth. So now the cycle. How does it happen? Most importantly, we have a two process, because we say the natural reservoir of phosphorus is phosphate rocks, which basically you can say lithosphere, are basically concentrated in what we call the phosphate rock. They contain a lot of phosphorus. And what are the processes that lead to mobilization? What are the natural processes that mobilize this phosphorus from phosphate rock? We said two processes include the weathering and the volcanic eruption. So the weathering will now, because weathering is one of the process of soil formation called pedogenesis, and we have a different agents of weathering, chemical weathering, biological weathering, because there are a number of them that lead to soil formation. So weathering can due to this chemical, physical, biological, can crush this rock, leading to soil formation, and the smaller particles can even wash down to the soil by the action of rain, and also during volcanic eruption, a lot of gases contain a lot of phosphorus, and once they get into the soil, although even even in the rock, the soil. So basically, they form a kind of salt with polyvalent ions, so which mostly are insoluble form, like they form calcium salts, aluminium salts, magnesium salts, and all these salts are insoluble. So even when they get into the soil, they are in form of the insoluble aspect. With the help of the rain, and then the microorganisms like nitrosomonas and thiobacillus have insolubilized. And how do they solubilize? Including even the plant themselves, because the plant also produce some organic acids. So the microorganism releases a lot of enzymes like phosphatases, and they also release acids, including the nitric and sulfuric acids, all in an attempt to solubilize these insoluble phosphate compounds, so that the plants and the microorganisms themselves can take up and use it for the synthesis. So when these microorganisms, the plants take it off, they store it in their system, utilize it for their own metabolic activities. Some of them will be washed into the river, and in the river they also combine with all this aluminium, calcium, iron to form a lot of compounds that over a long period of time can even deposit it at the deep end of the ocean, where they can sediment over a geological period of time, and that the process that leads to even formation of a rock. And also fish and some other things can take or can ingest a lot of this. We have these marine birds that can eat from lives from the oceans, like fish and the rest, and they themselves will contain a lot of this phosphorus. So when they go out to the lands and the pickets, their distance contain a lot of phosphorus. So this is how the phosphorus circulates to the system. So we, the animals, who get our phosphorus from plants, and when we die, decay, then we have these decomposers and actin oils, and they release this phosphorus, and the phosphorus will get back to this soil, washed into the river. When they get to the river, also they get deposited over a geological period of time. Some of them would now form part of the rock, which weathering also and the volcanic eruption get to release those phosphorus to the environment, and then this is how the phosphorus come into being. So this is basically the process. Like I said, I don't want to take much time here, because my system is going down. So what are the impacts? The impact basically is that human beings apply fertilizer as well, phosphorus fertilizer, which can lead to increase in the phosphorus in the soil. We also have industrial activities producing detergents and some other phosphorus emission into the river and the lakes, and this can actually cause a lot of contaminations. We have the mining also. You mine, and this mining can lead to exposure of the release of phosphorus into the soil. So these activities causes an increase. Remember, we said it is a limiting nutrient. So once washed into the river, the oceans, and the water bodies, there are a lot of like cyanobacteria that can fix nitrogen. But a phosphorus is only this process. So when you have a phosphorus and the phosphorus being moved to the river, the organisms in the river will enjoy because of the presence of that phosphorus. That is why in cases like in marshes or in rivers, when you see the cyanobacteria blooming, enjoying, where you will see a river that is completely green because of the growth of this algae, the cyanobacteria, what we refer to as algal bloom. So because of the presence of that limiting nutrients, which is phosphorus, because they can actually picks nitrogen. So there's nitrogen, there's phosphorus, and they can undergo photosynthesis, carbon. So water is already there, hydrogen and oxygen is available for them to use, and then they enjoy their life. And that's what lead to what we call eutrophication. And the eutrophication is basically because it to give a protective coverage to the water, so all the other organisms inside the water now will suffocate, will no longer have oxygen, will no longer have sunlight, and as such over some period they will die, they will decay, and then they will be producing all this smell. So basically that one will cause a contamination to the environment. So this is an impact to human, but how does that affect human? Oh, already I don't even, I've forgotten that I have this. So this is an algal bloom, and this leads to this eutrophication, and it creates a kind of repugnant smell, cause contamination to the environment, air pollution, and this also affects the water qualities, the kind of pose a risk to global water quality. And we also have this issue of phytic acids. Remember, we said when you have an excess of this phosphorus, of course, the plant will take off a lot, and then they have no option because they have more than required. Then they have to store it in the body in form of phytic acid. So this phytic acid is usually stored in the grains, the grain aspect. So when you take the grain, they contain a lot of this phytic acid. The phytic acid can also work to prevent the absorption of some micronutrients like iron, zinc, and calcium. By so doing, they can cause a risk of iron deficiency, anemia. So one of some of the challenges of the phytic acid. So what are these the mitigation strategies? The mitigation strategies of phosphorus basically is phytase enzyme can be used as a body supplement, so that when you take a food containing phytase, and then can break down the phytase, therefore the uplifting that risk of iron deficiency in these macronutrients. And we also have a genetic breeding where you have a plant that will contain less of phytic acids as the biochemist. And equally, you can also come up with a transgenic method using biotechnological tools, the plants that can no longer even store phytase. The synthesis of phytase is being disrupted. In addition to that, we also talked about biofertilizer, where you can employ the use of microorganisms, including the mycorrhizal fungi that facilitate the uptake through symbiotic relationship with plants. So you can facilitate that process instead of adding phosphorus fertilizer. So then you can be using those organisms, and whenever the fertilizer is available, the phosphorus is available, they can solubilize the phosphorus. Because even in some cases, you will find out that solubilizing the phosphorus is what is giving the headache. So if you have these organisms available, they can secrete acids, enzyme phosphatases, etc. They can release this and then solubilize, then taken up by the plant. It should be enough for the plant to grow maximally without additional adding from mining, etc. Just mining of phosphorus to expose a lot of phosphorus to the environment, and then this leads to a lot of the damages as we just mentioned. So this is about Phosphorus Cycle. If you have any questions, please take your time, listen to these videos, tutorials, then read on your own words, get your questions ready, so that when I come to the class, you can be free to ask questions. So that we just discussed and then talked about how we're going to have our tests, if possible, before the exams or on the exams day or any way we can arrange it, and then we can have it done in such that you people are not affected negatively. That, like I told you, we're running out of battery. So, thank you very much. We'll see for Solpo and then finally water cycle, and then we'll see some tutorial questions. Then from that, we'll round off. See you.